Hello everyone. Thanks for joining TremorCon. Uh, my name is Nagaprabhu Muthiya Sundaram and I'm based in Washington, United States. And I have been working logging, monitoring and observability domain for the last 10 plus years. And currently I'm working as an observability engineer for Wayfair. And today I would like to share some of our observability specific architecture and how Tremor helped in our journey. That's what I would like to share with you all. Observability. So just a quick introduction. Um, Anyone who wants visibility into our production systems, they would definitely come to our observability domain. And the requirements for observability varies from teams to teams, groups to groups. Um, there could be a set of people sitting in organizations, command centers, operation centers, and would holistically monitor all the applications running in production environment. And there could be a specific set of SRE groups, site reliability engineers dedicated to a domain, and they would want to uh, zoom down and then monitor their domain specific applications, and then probably they would go a little bit deeper when the issue happens. And finally, there could be an on-call engineer um, who would be working on a very specific team or the specific set of teams, um, and they would be drilling down to the logs if there's any issues, and then they are the ones who get paged at the night uh, if there are any issues. So the observability requirements varies from all the way to very high level monitoring, whether it's the system is successfully running or not, and drilling down all the deep to viewing the logs, traces, and then finding out where the bottlenecks are. And when we talk about observability, there are three main pillars: logs, metrics, and traces. Obviously, logs are time-stamped records of discrete events that happened over times. This would be the oldest pillar of our observability, and no matter whether if the team has sense of observability or not, obviously they will have some sort of logs where they want to go and uh, uh, use for their debug and triaging. But that's not the obvious and go-to place for all our monitoring needs. So we definitely want some graphs which holistically depicts the health of the systems. And that's when metrics comes to the picture, which gives the numeric representation of data over the time. Um, Precisely, that would say that for my given application, how many transactions happened in the last 1 second or 5 seconds or in a minute, and out of those, how many of them were succeeded, how many of them were failed, and if there are any latency issues, how much time it was taking to process the transactions, probably yesterday to today or week over week comparisons. So all those beauty jazzy dashboards will be driven with the metrics. And finally, the traces. Traces is another interesting concept. When we have everything in the monolithic applications, um, you just open one log file and then find out all the history, traces, and everything's happened on that application in that one place. But that's not a scalable solution. And then we break all the monolithic applications into smaller microservices, and we go into a distributed system. And when we go into a distributed system, we don't know who's causing issue to our applications. The teams or applications which you don't even know has the ability to impact your application. So the request could initiate at one place that could process into be multiple chains, and one point of place, boom, it could have broken. So in those scenarios, we need to debug that. We need the complete trace. So where it's originated, what are the hops it traversed, and where it failed. Or if there are any bottlenecks, each hop we need to measure how much time it took. So those kind of things would come under traces, finding out the spans, the individual applications, SLAs, whether it's been met or not. So everything would come under traces. So in Wayfair context, with respect to Tremor, we were extensively using uh, Tremor for logs and metrics. Traces, we are yet to go into that journey. Soon we would start on that. And this is our high-level signal flow. When observability signal is emitted from the production application, what are the hops that it goes through and how it has been stored. This is the flow that goes today in Wayfair. So the signals are emitted on the live application, and those are collected through a Tremor source layer. That's our first L1 layer. And then this setup is available in pretty much all the region. So we have 5 regions in our production environment. Every region has a Tremor source layer. They collect all the signals, logs, metrics, and then post it to local Kafka. And using Brooklyn mirror makers, we kind of aggregate all those logs into one master region where we will be doing all the message transformations, cleaning up the logs. If you wanted to enrich some of the messages with new elements or IDs, or if you want to do any transformations, everything would happen on that place. And then finally, using our Tremor sync layer, we would inject them into either Elasticsearch for logs or InfluxDB for metrics. As you can see predominantly Tremor is contributing in our pipeline. Let's dig deeper and see how else Tremor is helping and what are the areas that it's adding value to our observability domain. Okay, as I mentioned earlier, this is our high-level Tremor infrastructure that we have in production today. We have 5 regions running on GCP, and we have an active DR setup. And from a logging infrastructure perspective, our Tremor infrastructure alone contains close to 5,000 cores, and we process 100,000 messages per second at the rate. And for metrics, it's close to 4,000 cores and 4 million metrics per second. Obviously, we are doing a lot of rate limiting, but this is the amount of signals that we get from our application. And that's one of the plus in Tremor, that we will be able to cut down the noise at the source with all the rate limiting capabilities what Tremor provides. So let's dig deeper into it. Okay. So now just diving a little bit deeper, the Tremor source layer. This is the one which sits as close to our live applications, and whenever a new application has been onboarded, a new protocol has been introduced, and our Tremor source layer is capable of adapting to that the new system. And this layer is very lightweight. We do not want to overload our production side of the system with any high processing or any transformation. And our data sources are very heterogeneous. Some of our application logs are emitted in a TCP protocol. Some of them comes through UDP, and some of the logs in JSON format. Some of them are plain text, and some application directly post to Kafka, and then we read it from Kafka to process them. And even RSS log has also been used in some cases to read the syslog files and then post it to Kafka. So with all this heterogeneous setup, Tremor is able to Tremor provides pretty much all the on-ramp to tap into all these data sources and then start collecting the metrics. And from our point of view, just expose different on-ramps, and then once we collect the data, we aggregate them and then push it to Kafka. And all the downstream processing happens from the Kafka layer itself. So, no, we take it from Kafka and then we do the transformation and ingestion into the DB. Okay, this is one of the sample work that we did, not the sample work, recent migration work that we did. We migrated one of our component that was using Logstash to process the logs, to collect the logs, rate limit it, and then write it into Elasticsearch. We migrated it. The point that I wanted to share in this particular slide is, so if you look at the distributions, this is a Kubernetes logs. Applications running on Kubernetes, they emit the logs, but the distribution was not even. They were, with the Logstash, we had one rate limit set, and any high volume application runs, and they used to occupy more of the rate limiting bandwidth, and some applications did not even record anything into our logs. And Tremor has a beautiful feature to rate limit based on a dimension, and when we migrate, we make use of it, and then we made namespace as one of the dimension. And once we move to that, obviously our the CPU utilization has come down significantly that we expected. It was very Tremor was very powerful, uses less memory, very efficient. So the CPU came down. Apart from that, from the functional perspective, we pretty much got almost the same amount of data from all the application logs, because now the new rate limiting was specific to that namespace, not just the whole on ramp or the whole set of data. So now pretty much all the applications owners are getting the same amount of data and the same amount of rate limiting capability. So that's one big win that we recently observed with Tremor. And then, so in the Tremor source layer, we saw how we were able to pull the data from all different types of data sources, no matter how heterogeneous it is. Tremor provides options to pull from TCP, UDP, FileBeat, Kafka, RSS log, whatnot. And on the Tremor transform layer, we aggregate the metrics, and we will also do a lot of transformation. If someone wants to normalize any specific field, like during the application time, they could have created a field called customer ID, and but when we normalize it, when we store it into Elasticsearch, we don't want to store it in our 5 different flavors of customer ID, customer underscore ID, customer ID, CUST underscore ID. So we do one level of normalization for the known keys, and bring all our log signals into a consistent format. There are some sources which just emits text files. Some of them comes in the JSON format, and when it comes to our transform layer, we kind of transform all of them into a common JSON format and then write them into Elasticsearch. And when we talk about metrics, we do a lot of aggregation there. So if anyone wants to store their metrics for a longer period of time, we do not want to, we'll just compensate on the granularity. Instead of storing per second metrics, we'll just roll them up and then store it as 1 minute metric and 10-minute metric and 1 hour metric, and then those would be stored for a longer period of time. And Tremor helps us for our aggregation as well. And when the logs comes in a very high volumes based on the message type, if you wanted to write into 2 different databases, 2 different Elastic clusters, or if you want to route it to 2 multiple indices, so all those routing logics have also been handled in our Tremor transform layer. So even for the message transformation, we extensively use Tremor. And finally, the Tremor sync layer. This is the one which which writes the data into a final database. We would batch all the records as much as possible and then write it into either Elasticsearch or InfluxDB for metrics. And okay, before I go to Kubernetes, go back. So it's the Tremor source, transformation, Tremor sync, everything provides the functional. It's not just uh, uh, those areas. Tremor also provides the monitoring of monitoring, and every layer we were able to capture how much message has been ingested into Tremor system and how much has been processed. And during the process, if any of the messages are got dropped, or if you're not able to process any messages, if it's failed, Tremor itself emits all those metrics uh, in an InfluxDB format, and we capture them, and then we use it for our monitoring of monitoring. And by that way, in that way, if someone comes to us and then say that, hey, we were we were writing 50 messages and we are seeing only 10 messages in our logs, then we are able to precisely point that, hey, this is your application, yes, and this is emitting this much amount of records, but in Tremor layer, we are explicitly dropping or rate limiting X number of messages. So, yep, your application is emitting more, and we are able to quantify it. So the monitoring of monitoring is also a very important feature that we leverage out of Tremor in our observability domain. And when we go to this is another area where we use Tremor to collect the Kubernetes logs. We collect the ingress logs, which is running as an Nginx daemon set, and Tremor also used to convert some of our RSS log formats messages into JSON message there, and we collect Docker container logs and Kubernetes events and audit logs. So you can, if there is logging, transformation, metrics collection, then we could see Tremor in action in Wayfair. So, and thank you so much for listening into this video. And if you have any questions, we would love to take. Thank you.
Well, that was the but one minus the last talk for today. First of all, Naga, to my left, thank you so much for agreeing to speak on TremorCon and sharing your experience with using Tremor at Wayfair. Would you want to introduce yourself to the audience and say a few words? Who you are, what are you doing?
Thanks, Matthias. Thanks for arranging this excellent TremorCon, and it's fun watching all these great videos. And hey everyone, I'm Naga, and I'm an monitoring, logging, and observability engineer. That's what I want to visibly. That's how I want to project myself to everyone. I was in this logging and monitoring domain for more than 10 plus years, and I've been worked with a couple of payment industries and cloud providers. But most of the times I worked in the login and monitoring domain. And after I was been working as a staff engineer in Wayfair for the last close to 1 year. And since the day one, I've been working with this Tremor. So that's one of our key component, which plays a major and a vital role in our pipeline. And I'm so excited to continue to do more magic works in our domain using Tremor.
That's nice to hear. So you started your journey in Wayfair when we already had migrated to Tremor. And I think one of the things you can speak to better than most other people is Tremor takes a bit of a different approach for configuration. You effectively write programs in Tremor script and trickle. for aggregations. It, how did you experience that? What was that of a change for you?
Oh yeah, that's a very great question, and I'll the moment that I saw this trickle setup, it was very fascinating, and it was so natural than how one would visualize their data flow, their pipeline, how they wanted to visualize, and that you're putting it in a simple script, which is very elegant and more readable and user friendly. So that part was very nice, and then we also have that the options to bring our scripts into a pictorial format, and then which always tells that what are the nodes that we have, what is the flow that it gets, and if there are any errors, any separate ports that we are routing our data where it goes. So it also gives us that the pictorial representation of our scripts. So that was really awesome. And even after I joined, it's not Tremor was there 100 percentage. There are very few components were running on some old legacy stuffs, not legacy, some traditional stuffs like Logstash, and we did the migration from there to Tremor. So that journey was awesome. So you go and look at something which is very traditional, how people would implement, and then you migrated it to Trickle script. So that journey was really awesome.
That's good to hear. If you had the magic lamp and a wish, what would be your wish that changed in Tremor? Where did we screw up and didn't do a good job? Where are we hurting you, Naga?
Uh, See, it's not a hurting factor or anything, but hey, if I want this means probably we would say that the clustering feature. I know that Tremor team is already started working on it, and they are progressing great. Um we have uh, multiple deployments of Tremor in our production instances, and we definitely want our configurations to be in sync within that cluster, and we don't want uh, any other external configurations tools to take the responsibility of updating the configurations on all the nodes. We always knows that things break. Uh, some of the nodes could be left out of the loop, and they didn't get the proper configuration. That is not something that the users or customers want. But the clustering features uh, that the Tremor teams you guys are working on, that's pretty awesome. And that's probably, if you would have seen that feature a year back, then
Would have
by the
been
time
nice.
we migrated, at the time itself, so we could have caught up all those cool and jazzy things. Yeah, that would be the only thing that I can think on top of my head. Yeah.
That's really really good feedback, and we really want to get that done.
Yeah.
So you're bridging an interesting divide, not divide, interesting river. Um, on the one hand, you are working internally in Wayfair with Tremor as a internal customer or stakeholder. On the other side, you are also in the open source community. How does this two sides of being part of a community, the internal and the external one, work for you? How does this influence your work, your daily to dos?
Oh, that's a very excellent question. Um, the moment that we contribute something to the open source, I get the feeling that, oh man, you are taking something from the internet and then keep using it for all this close to 12, 15 years. What have you contributed back? And okay, Tremor gave opportunities. Hey, yes, it's not that you're contributing back to the society and you're also implementing it in your project. You work on your day-to-day activity, you find something that's very interesting, and you want that new feature to be there because it's really needed for your job, and you are doing it. Everything is for your bread and butter, and you're also contributing to the open source community. That's a great feeling. So I never felt that I'm spending anything extra time or putting any extra effort to work on an open source project. I'm doing my day-to-day work, working on the actual projects that has been assigned, which has been contributing to Wayfair's values and our
Yeah.
goals. And on top of it, we're also contributing to the open source. So yeah, that's a great feeling.
We touched on this, or both you and Gary touched on this a bit. That's cost savings. Where do you without divulging any sensitive information, of course? Where do you think there is still an opportunity left for Tremor to improve on that front?
Wow, okay. So we have seen some visible improvement when we migrated from platform A to Tremor. So straight away we were able to cut down some 50% of our CPU cost. So straight away we cut it down, and then even after we cut down by 50%, there were enough headrooms to grow. Um, so most of the times we saw the plus points of the Tremor, and probably if I dig a little bit deeper, I would be able to see, hey, you guys are doing this. Probably if you cut it down, then we'll be able to cut down from 50% to probably 20% or 30%. So
Oh,
we
nice.
don't we don't have to over engineer anything. But this is my experience.
Yep.
So we when we migrated on the straight, boom, cut 50% of our infrastructure cost. So again, it's one good
Yep.
thing. Probably
It is.
I'll catch what are the negative side of it later.
A shout out from Natalie on the chat. She says she loves your open source sentiment.
Sure, thanks.
So we only have a few more minutes left before we go off into a break. Is there anything interesting you or the team are working on you can share with the audience? Something interesting going on? Some plans for the future?
Oh yeah. Um, we are keep on working to optimize our infrastructure, reduce the cost, provide the better availability on our logging platforms to our customers. So having said that, we are reforming our pipeline. So again, Tremor takes a major part in it. Uh, we are trying to do some early rate limiting, so that our infrastructure's cost would would be reduced. So we have an amazing Kafka infrastructure, but sometimes we feel that we are taking over advantage of that. And by reforming our internal pipeline, we would be able to use all those resources in a more responsible way. Um, then use it only when needed, and then um, so that's one key feature that we are working on. We are also trying to provide a little bit of control to our customer. Most of the times, in a logging world, what I have felt is, you emit some signals, either it's logs or metrics. 90 or 95% of the signals are not at all used. Very only when it is needed, people jump into the screen and then see. But even 90% of them are noise. They don't need it. So why the developers are not cleaning it up is, okay, I have to go through a long process, raise a couple of tickets, follow up with them. Why should I do that when I have other work which would add some real business value? So to address that concerns, we are giving some control to the developers so that they themselves can go and tune their configurations. Hey, I'm emitting X amount of signals, and I want to dial it down to Y percentage. So we expect that the developers would also take some responsibility and then do some cleanup from their side. So we are just delegating the responsibility to them.
Makes sense. Wonderful. Naga, thank you so much again for coming by, for giving this really interesting talk and having this wonderful Q&A with me. We'll see you around in the Discord, I'm sure. If anyone has questions for you, they can probably catch you there. Probably not today, because you're technically on holiday, aren't you?
Yeah, US guy,
sorry,
Labor Day.
sorry for that. So enjoy the rest of your day. And we'll break for another 15 minutes, coffee break, and then continue TremorCon with a last talk from Anna called Crabs with Instruments, which is going to be exciting. And at the very end, last but not least, a coffee chat with the Tremor team and Natalie from Wayfair's open source project office. I did it wrong again. Program office. God damn it, Heinz, you had one job. Anyway, we will see you in 15 minutes.
Okay.
And
Thank
enjoy.
you.
Again, Naga, thank you. Bye-bye.
Thanks.